Teacher Samson. In this video, I'm going over some problems associated with science paper 1, physics 2017 G.c.e. So I'm going to do the part B, but so let's begin. B1 figure B1.1 shows a part of vernier caliper. What is the reading of the vernier caliper? So you need to understand what a vernier caliper is. A vernier caliper is an instrument used to measure the internal and external diameter of a pipe. So a vernier caliper has two scales. It has a mini scale and a vernier scale. So how do you get the reading on the mini scale? This is my mini scale. If this is 8, this is 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8, 8.9, then 9. So to get the reading on my mini scale, I should get the reading before the vernier scale. So if this is 8, going backwards, this is 7.9 because I have to get the reading before the vernier scale. So if this is 8, this is 7.9. So my mean scale reading is 7.9. Now, once collected the get the reading on my main scale, now I can get also the reading on my vernier scale. So on the vernier scale, you count where they're meeting with the vernier scale and the main scale. Where they're meeting, that's where you have to get the reading. So this is 0, 1, 2, 3, 4, 5. At 5, they're meeting the vernier scale and the main scale. So I'll record 5. Now this 5 is accurately to 0.01 because it is in centimeters. So centimeters. Always whatever it is has to be accurate to that number if it is in centimeters. But if it's in millimeters, it's different else. So now 5 times 0.5, I believe it's 0.05. So now I can say 7.9, 0.05. Let's add the reading. So the reading, it's 9.7 centimeter. So this is my reading on my vernier scale. 7.95 centimeter. I'll go to part B. Write in symbols, my apology. Write in words the SI unity of the following physical quantities and state their symbols. So velocity, SI unit in words. So the SI unit in word is meters per second. The SI unity is meter per second. Temperature is measured in Kelvin. The symbol is just letter K. Acceleration is meters per second square. So the symbol is mv squared. This is the symbol. So that's it for this problem. You can go to another one. Second question. Okay. What is the difference between B2? What is the difference between density and relative density? So, density is a mass per unit volume. Wow, relative density is the ratio of density. So, density is mass per unit volume. Wow. Relative density is the ratio of density. Just one mark. Or in other words, you can write density has unity, while relative density has no unity. So both answers are correct. Go to part B. Our figure B 2.1 shows a cubic container that has a 5 cube base and contains water to a height of 6 centimeters. What is the volume of water? So to find the volume of water, volume is equal to, look at the shape, is L times B times height. So my length and my breadth and my height. So I have 5 times 5 times the height, which is 6. So 5 times 5, 5 times 5, that's 25. Then 25 times the 25 times 6. 25 times 6. That's 150. So this is the volume of water. It's 150 cubic centimeters. Now, go to part 2. A stone is immersed into the water in the cubic, causing the water to rise to a height of 8 centimeters. Determine the volume of the stone. So, if the stone was immersed, the stone was immersed into water and causing the water to rise to a certain height. Now, what is the volume of a stone? So, how are we going to find the volume of a stone? Uh, when the stone was immersed in this water, the water level raised to a certain height. So we need to find the total volume of a stone and the waters of a regular stone. Okay, so we use the same formula. Water, volume is equal to L squared times height, which is 5 squared times the height is 8 now. So 5 squared, that's 25 times 8, get a 200 centimeters. So this, it's a total volume of water and a stone. But how are we going to find the volume for a stone? So to find the volume for a stone, I have to do this. The volume for a stone is equal to V2 minus V1. So the volume for a stone is 200 minus the volume of water, 150. So subtract the volume for stone is equal to 50 cubic centimeter. So it's 50 cubic centimeter. We go to part C. So part C, if the mass of the stone is 80 grams, calculate the density of a stone. So density is given mass over volume. So the mass of a stone is 80 grams divided by the volume of a stone. So the volume of a stone is 50 cubic centimeters. So what is the density? Eighty divided by 50. That's 1.6. That's 1.6. The unit is grams per centimeters cubic. 1.6 grams per centimeters cubic. That's it for this problem. Come to this problem. Question B3. Figure B3.1 shows a ram being used to lift a box weighing 480 Newton through a distance of 3 meters and a height of 1 meter by applying a force F of 200 Newton. State the meaning of the term simple machine. So a simple machine is just a device used to lift. A simple machine is a device used to make the work to be done easily. Or a simple machine is a device that simplifies work. So simple machine is a device that simplifies work. That's a simple. Calculate the mechanical advantage of a lamp shown in figure B3.1. So mechanical advantage is equal to load over effort. So the load of a box is 480 Newton. It's 480 Newton divided by the effort. The effort is 200 Newton. It's 200 Newton. So notice the newtons will cancel and the zeros will cancel. And this is just 48 divided by 20. 48 divided by 20. That's 2.4. No unit. 2.4. Mechanical advantage has no unit. So it's 2.4. So write 2.4. That's my mechanical advantage. Calculate the efficiency of the lamp. So efficiency is equal to mechanical advantage over velocity ratio times 100%. So mechanical advantage I have is 2.4. I need to find the velocity ratio. So velocity ratio of an inclined plane, this is inclined plane, is equal to distance moved by load over distance moved by effort. So my velocity ratio is equal to distance moved by load, and this is effort. So the distance moved by load, so this is the distance moved by load from this point to that point. That's a 3 point. That's 3. Then the distance moved by effort, this is the distance moved by effort. Your goal is to push this box, to lift the box from this point to that point. So when you look at from this point to that point, it's a distance moved by load, and the distance moved by effort is just 1 meter. So it's 1 meter. So my velocity ratio is equal to 1 to 3. That's 3. So that's my velocity ratio. My velocity ratio is 3 times 100%. So I need to divide 2.4 divided by 3 divided by 3 is 0.8 times 100. 80%. So get 80%. So this is the velocity ratio. Oh, this is the efficient. Now, you may be asked, why is that the efficient is not 100%? The efficient is not 100% because there was some loss of energy due to friction force when the box was being pushed to the up. There's a loss of energy. There was a friction force which pushes the box to this direction, and the force, there was an opposite force reacting. We go to question 4. Okay, figure B1 point shows a glass cylinder with a sealed tip containing a gas at an initial pressure of 360 pascal placed in hot water. After a few minutes, the piston in the cylinder moved up. So the question is, use the kinetic theory. Explain why the piston in the cylinder moved up, up when the cylinder was placed in hot water. So the air molecules gained kinetic energy and increased in their motion. Hence, the collision of air molecules with the hole inside the cylinder increased, which resulting in the increasing pressure inside push the piston upward. Write that. Air molecules gained kinetic energy and increased in their motion. Hence, the collision of air molecules with the hole inside uh, with the hole inside the cylinder increased, which result in the increase of pressure inside. Pushed the piston upwards. All right, that's it. Part B, the piston was pushed downwards to 20 cubic centimeters while the temperature was kept constant. In terms of in terms of the kinetic theory, explain why the pressure of the in terms of the kinetic theory, explained why the pressure of the gas in the cylinder increased. The volume was reduced. This is because this is because the volume was reduced, which reduces the space, reduces the space between the particles, between the particles. Hence results results in high pressure. So high pressure. Okay, go to part 2. Calculate the pressure of a gas in a cylinder. So we need to write the data first. Let's look what we have. All right. Our general formula is given by this. Pressure is equal to P1 V1 is equal to P2 V2. So the data figure B shows a glass cylinder with a sealed tip containing a gas at an initial pressure of 360 pascal placed in hot water. So that's my pressure 1. My P1 is equal to 360 pascal. The pressure is a force acting per unit area. After a few minutes, the piston in the cylinder moved up. Using the kinetic theory, okay, so the piston was pushed downwards to 320. Okay, I think it was pushed down to 20. Okay, so let me first look at this piston. This 0, this is 20, and this is, I believe, no, I'm not really sure. I don't know this figure, but this is 60. So this 60 is my initial pressure. My initial volume. So my V1 is 60 cubic centimeter. So this is the volume initial volume before it was pushed downwards. So they're saying that the piston was pushed downwards to 20 cubic centimeters. So this is my V2 now. My V2 is 20 cubic centimeter. So I'm finding the P2. So we can just plug in the values that we have in this formula. So my P1 is 360 pascal times my V1, that's my 60 there. I'm looking for P2, my V2, that's 20. So times 20. So I have to make P2 the subject formula. So divide both sides by 20 and even this side by 20. So the 20 will cancel, and 20 into 60 is 3 times. So 3 times 0, that's 0, and 3 times 6, that's I believe, let me do that. I believe it's 18. Yes, it's 18 carry 1, 3 times 3, 9 plus 1, 10. So this is the P2. So therefore, my P2 is equal to 1080 Pascal. So we can just put that answer here, 1080 Pascal. Okay, I go to question 5. Figure B 5.1 shows a variation region of the electromagnetic spectrum. So K, LM, visible light, ultraviolet, and O. What is the name of the component? Component N. So where's component N? After ultraviolet, the N is X-ray. So my N is in X-ray. X-rays. So make sure that you go and start this and master it to your head. So this is just the order according to the increase in frequency. It's just the order of increase in frequency. So give one practical use of region M. So what's the first region M? You need to identify region M. After invisible light, the back there is infrared. So knowing that M, let me just write that M is infrared. Infrared. So what's the function of infrared? So they're used for car paints. They're used for car paints or in remote control, e.g. TV and etc. etc. Part C. State one property which in the same for all electromagnetic waves. So one property, they can all travel. They can all travel through vacuum. Through vacuum. That's the answer. Part D. Set one possible source of the radiation from region O. So what's a region O? After M, we define that N is X-rays. So after X-rays, there's gamma rays. So know that O is gamma rays. So what's a source of gamma rays? So the source of gamma rays is radioactive nucleus, mostly found in radioactive nucleus in cobalt. Question 6. B6, figure B6.1 shows a converging length of a focus length 2 points used to produce an image of an object 2 centimeters tall and placed 5 centimeters from the length. All right, so for this one, I will just do it for rough sketch since I don't have a ruler with me. But I'll explain how you need to do it. So you need to measure 5 centimeters from length. You measure from this point, you get your ruler you measure 5 centimeters. Assuming that this is my 5 centimeters from length, from the normal length, then my object has to be 2 centimeter tall. So it has to be 2 centimeter tall. So you measure also using your ruler. So let's say assume that this is 2 centimeter tall. It's 2 centimeter tall. Now we're going to use this information. So they're saying draw the scale on the figure array diagram to locate the image formed. Right. So you're going to use your ruler straight. Make sure that passes through the normal straight. My apology, just that I don't have a ruler with me. Straight has to pass straight. Oh, one thing that I've forgotten, you can indicate this is F1 and this is 2F, and this is F1 and this is 2F again. Then next, this has to be straight line. Hey, and has to also to pass through the F1. Make sure that you use your ruler when doing this. Right. So where they're meeting at this point, I'm assuming that it was formed, the image was formed just on 2F. So the properties, this is a real image because it has been formed, and found to its upright and etc. So I believe you have understood this one. I can go to part C, calculate the magnification of the image. So magnification, just represented by M, magnification is equal to the height of image over the height of object. I'm assuming that this height, I'll just assume that this height is 1. So you have to use a ruler. You measure from this point up to this point. You measure the using your ruler, the height of the image. Just assuming that it's 1 over the height of object. So the height of object is already given, which is 2. Want to find the magnification. So magnification is equal to 2 into that, you get 0.5x. So it's just 0.5. You have to use x. So it's 0.5x. We go to question 7. Right. Question 7. Figure B. B 7.1 shows a magnetic field line between the poles of 2 magnets. So I have a magnet and there is R. So name point R. So R is neutral. This is neutral. Neutral. If P is a south pole, what are the poles Q and T? So if P is a south pole, if this P is a south pole, then it eventually this one is a north pole. So this one is a north pole. So a magnet has a south pole and north pole. So this is north pole. Then what could be T? If this is north pole and this has to be south. Oh no. sorry, if this is North Pole, as you can see, um, the direction of these magnets, it's mean that they're unlike. So eventually, this has to be north. This has to be north, and also this has to be north. They're not attracting to one another. So it means that T is South Pole. There's a repel. Explain how soft iron keeper. Sorry. Explain how soft iron keepers help magnet retain their magnetic for a long period of time. So I think my answer, the soft iron keepers prevent magnet field line from coming out of a magnet. I think that's all. Then we go to part D. State two difference between iron and steel as a magnetic material. So iron is easily and strong to magnetize. While steel is hard and weak to magnetize. So that's one. Now iron is used to make electromagnet, while steel is used to make permanent magnet. Go to question 8. Figure B 8.1 shows 3 resistors connected to a 12 voltage battery. Calculate the effective resistor between X and Y. Okay, so I think there was a typing error for this one. So to calculate the effective resistor is the total resistance connected in a electrical connection. So we need to find the resistance connected in this parallel, and we find the effective resistor. So let's find the resistance connected in parallel. So the total resistance connected in parallel is given by this formula: R1 times R2 divided by R1 plus R2. So my R1 could be any 12 times 6 divided by 12 plus 6. So what is 12 times 6? 12 times 6, 72. Then 12 plus 6, that's 18. So I have to divide that, the number, by 18. So 72, keep making mistakes. 72 divided by 18. That's 4. So that's 4 ohms. 4 ohms. So this is the total resistance in power. But I want to calculate the effective resistance. So to find the effective resistance, it's R1 plus R2. So R1 is just 2 ohms plus R2. This is the resistance connected in parallel, which is my 4 ohms. So my effective resistance is equal to 2 ohms plus 4 ohms. That's 6 ohms. So I have 6 ohms. That's the answer. The current, calculate the current flowing in the battery. So current, use the Ohm's law formula. Voltage is equal to current over voltage. So the current, we know the voltage of the battery is 12 volts. It's 12 volts, and we're looking for current. And the total resistance which is connecting this circuit is a 6 ohms divided by 6 ohms, and even this by 6 ohms. So the 6 will cancel. So the current is equal to 2 amps. No, current is measured in amps. So my current is 2 amps. That's it for this one.